The idea with the Projectile Motion Lab is to basically compare results when there is an angle and when there is no an angle of with respect to the ground. Let me just show you the simulation so you can see what I'm talking about. So this lab, the Projectile Motion Lab, is actually a bit more simple. You're going to be exploring just two parts. The first part, you are going to be launching the projectile horizontally, what we call it as free fall projectile motion, basically because you just launch the mass and it does that trajectory. Now, you have a whole bunch of data here, but I want you guys to do some calculations. I know that this gives you basically everything you need to know about the motion, like the time it takes, the V on X, V on Y. These are, by the way, values at the end, right? That's why here you have negative 23 because it's negative 23 going down and 6 meters per second going to the right. 11.5 meters will be the horizontal distance. So those are values that I want you guys to calculate. You can always use the simulation to verify your values, and you can take snapshots to show me that you did the experiment or the simulation. But it's a good idea that you practice this because you're probably going to get a question like this in the lecture. So take this lab as a way to practice the equations that you are using in the lecture to solve problems on free fall projectile motion or projectile motion like this, right? I'm sure when you do this lab, you will have explored this in the lecture and you will have been introduced to vector components, the Vx, Vy, Vx initial or Vy initial, Vy final, and the fact that projectile motion basically is a combination of both free fall motion and horizontal motion at constant rate. So there is no acceleration on the x-axis. There is only acceleration on the y-axis due to gravity. Now, let's take a look at the instructions so you know what you need to do and where you need to, or what you need to be focusing on. So when you open the Projectile Motion Lab remote, you have here a snapshot of the simulation, and you have here a few instructions. I will add that you should also remove this. Just so you know, just so you have the simulation similar to what you will do in a lab. If you were doing this projectile motion in the lab, you will have to measure everything, horizontal distances, angles, and then you will have to use the launcher to find the initial speed of the mass. You are given all this in this simulation, but that's not the point, right? The point is that you actually try and explore this software, and as I said, understand the equations of motion of when you do projectile motion, right? How you use them. So here it says that you're going to be launching the projectile horizontally, like I showed you at the beginning, and you should place the ball at a height of 20 meters. Of course, you're going to repeat this procedure for 3 different values of height. So what this means is that you are going to remove this and this, place this at 20, and have the speed like that. You can launch it, and then you have the horizontal distance, but you also have the initial height, which is 20. So there is no vertical initial velocity. So 20 is equal to 1/2 gravity times square. That equation is given in a procedure. You can use that to find the time it takes to be in the air. And then you can use the horizontal displacement and the time to find the initial velocity, which is Vx. Vx is given here, so that means you're going to do an error percentage between the experimental one, in this case the one that you get from the simulation, and the theoretical. In some cases, you may get exactly 6. or whatever you give it here, right? Because you can change that as well. See, you can change it to 10 and then there. That's basically part one. You're going to be doing this for one height for, let's say, 25. You can vary the speed as well, to make it 8, and then. So there you are. So you can do it like for 3 different heights, for 3 different values of initial speed, and do the comparisons. Okay, so in this case, you're going to be exploring the vertical motion and the horizontal motion. That's the idea with this with the first part of the lab. The second part, you're going to be predicting the range of the projectile. So here is where you have to be a bit more careful, because you are going to be launching the projectile like this, sort of. There are some instructions though. You are going to repeat this for 3 different values of height again, but your height should not be below 20. So between 20 and 50 meters, and your velocity vector should not be less than 10 meters per second. So start with 24, let's say. Well, 23. And then you want this to be around 12. The angle should be between 30 and 60, I believe. Let's see. Yeah, between 30 and 60. So right, leave it like that. Almost 37. V is 15, yeah, no more, no less than 10. And then you launch it, and then you will see the mass. Okay, if that happens, so I gave it too much. Again, we can do the same height. Let's give it maybe 11 or 10.8 and 33. So that will work. So you have to play with this a little bit. Okay. All right. I forgot to do this. You see why you want to click this off? There. You can find here the initial horizontal velocity, the initial vertical velocity, the angle of the projectile with the horizontal, and then this is a resultant. 10.8 will be this blue vector here. So you're going to break the vector into components, and then you're going to be solving theoretically and find the range. Okay, so the way you want to do that is you want to do this at some point in the lab, but this is initial. The range is equal to Vx times time. Now, the time is equal to the time to go up plus the time to go down. The initial height is equal to 23 meters. So you want to know how much it goes up first. So going up, Vy initial is equal to 6 meters per second. Vy final, as you know, the velocity at the maximum height is 0 meters per second, and the acceleration is the gravity. So you can find the time to go up. So T up, you do B final equals to B initial final minus gravity time to go up. B1 final is 0. So that's equal to 6 minus 9.8 time. So time is equal to 6 over 9.8. Okay, that's the time to go up. Then you want to find also you want to find how much up it goes from 23 meters. That will give you using the equation B final y squared, B final B initial on y squared minus 2 gravity, let's call it h. This is 0. 6 squared is 36 minus 2 times 9.8 is 19.6 times h. So h equals to 36 over 19.6. You see, so you are doing all the equations of motion. 6 over 9.8 is the time to go up. So this is the extra high it goes. This height here that I found is this height. Is this one here. You need that because the projectile goes up and then goes down. But it goes up and then it goes down this height plus 23 meters. That's basically what you are doing. Right? So if I were to find the value using the calculator, right? Let me just give it a second. Here, you will do 6 over 9.8. That's approximately 0.60 or 0.6. And 36 over 19.6. 1.8 meters. The total height going down is equal to 23 plus 1.8, which is 24.8 meters. So 24.8 meters is equal to free fall, 1/2 gravity time to go down square. So the time to go down, if you solve that, will be 24.2.8 multiplied by 2 divided by 9.8, and then we take the square root, 2.2. Yeah, 2.25 seconds. Well, 2.2 actually. 2.2 seconds. The total time is equal to 2.2 plus 0.6 equals to 2.8 seconds. There you are. Say, look, 2.8, 2.8 seconds. So the range again will be V on X times 2.8, and that will give you approximately 25.2 meters. We go here. That's approximately what we get, right? According to that. So that's what you have to do. I know that this lab will be easier to do that simulation, but you need to have a good theoretical background. So as I said at the beginning in the videos, I will be doing office hours if you have any questions. I don't think you're gonna have problems with the simulation because this gives you all the information you need, but you need to show this theoretically. Once you do it for one height, you can start doing it for different heights. So you can do it for here, you can reduce this, or you can increase the angle actually. That's what I will do. And look what happens. Right? So different velocity X and different velocity Y, different time to reach the ground. So I want you guys to explore this because as I said, this will reinforce your ideas on projectile motion. Okay? So if you have any questions, please go through the video. It's only 2 sections. Once you finish that, you have to do some comparisons. And then you have to draw a diagram indicating all measure. So this has to be just one diagram. And then it says here, reset a simulator and check what happens when you launch a different. So this is just what you have to do here. And then you have to explain the differences between your theoretical and experimental values. All right. So I will leave it like that today. And if you have any questions, remember you can send me an email at any given point.